Right, hello guys, welcome back to John's Workshop, and in this video we're going to do another workshop tips video. These seem to be quite popular, and this was a request from one of my viewers and subscribers. That's Ralphie. How you doing, Ralphie? So Ralphie suggested something to me on my last workshop tips video that I put out a few weeks ago, and I thought that's a cracking idea. So what we're going to do is have a deep dive into coolant and the use of it. So we're going to work a little bit through, what is coolant and why do we use it, where do we use it, the different types of coolant that you can use, different applications. A lot of this is driven from my industry experience. I'm no expert, I'm no chemist, and believe me, there is a chemistry behind coolant. There's a lot of chemistry behind coolant, especially in aerospace applications. You wouldn't believe the amount of work that goes on in the background in terms of testing and validation and goodness knows what else. So there is a lot of chemistry within coolants, but not necessarily so much in the home shop. A little bit on safety, I'm not going to go nuts on that, and a little bit on how to use it. So without any more waffling, let's dig in. Okay, so you can see a fine array of coolants laid out on the milling machine. And yes, they are all coolants, every single one of them. I'm not pointing at anyone in particular, but they are all coolants. And why is that? So I'm going to address the first question on the board. What is a coolant? So coolants have 3 or 4 predominant uses that they're designed to do. And as the name suggests, they're designed to cool. So they're designed to keep your workpiece at a constant temperature. That's the first major use. The second major use of coolant, and this is one that people often don't understand, is they are designed to reduce the coefficient of friction between your cutting tool and your component. Seems obvious when you say it like that, but that's absolutely what they're designed to do. And everywhere you've got friction where 2 pieces of material rub against each other, which is the case for any machine tool when you're cutting, you will have friction, and any reduction you can get in that friction does many things. It reduces the wear on your cutting tool, it improves your surface finish, it keeps the part even cooler because you generate less heat. There is a lot that it reduces the pressure of a cut because of the reduction in friction, meaning you can physically cut more with the available power that you've got in your machine tool. There are a whole manner of predominant reasons why coolant is used, and that they're the key ones in terms of that friction reduction, if you like. A third one that's used, that you don't necessarily think about, is you could use water and you could use Guinness. It is a liquid. If you chucked this all over a road in large quantities and drove over it with your car with slick tyres on it, you would skid and slide all over the road because your coefficient of friction between your tyres and the road has disappeared, and that is why you have treads on your tyres. So any liquid is a friction reduction material if used between 2 mating surfaces. So any particular liquid at all, and I've got one here which is just alcohol, very good for use on aluminium, things like that, as a coolant. So lots of different coolants. So they're the sort of 3 primary reasons. I think corrosion resistance is another one. You're going to be squirting this all over your machine tool. Obviously you don't want your machine tool getting rusty and your components getting rusty and your tools getting rusty. Obviously Guinness wouldn't do a very good job of that. It works quite well on humans, by the way. But the rest of these have got an element of anti-corrosion properties built within them, with the exception of alcohol, of course, which doesn't. So they're another use that why we use coolants and what needs to be built into them. In industry, and I've got to admit in my most recent role I've moved away from the cutting edge of machine tools for the last couple of years, so I might be slightly out of date with these numbers. Coolant is a whole different thing these days, and it's not only used for the things that I've just spoken about, it's also used at extremely high pressures, and I'm talking 150 bar was common on most CNC machine tools, or certainly most high performance CNC machine tools. A couple of years ago when I was closer to this, I would no doubt that that's gone up a way by now, and we're probably talking 200 bar you know, huge pressures. And why do they use pressures like that? Well, because if you point that jet of coolant at the right part of the cutting tool and the component, you can get really good swarf control. So the coolant is so strong that it makes you break a chip even if you wouldn't do normally. And in a CNC machine, that's exactly what you need, because you don't want to be stopping it every 2 minutes to rake long curly bits of swarf out. So high pressure coolant is used in extreme pressure on CNC machines for chip control, as well as all the other things that we've just spoken about. So there's a whole manner of uses for coolant, and a whole load of reasons that we use it, and a whole range of different types of coolant that can be applied for different situations and different circumstances. So I think that's got us around, you know, what is coolant, what are the things that we need to consider when we're using it. So why do we use coolant? I think I've already covered a couple of those kind of use cases. So obviously, as I said before, to keep the part cool. Now that might just seem common sense, but again, if you're doing fine limit diameters and things like that, and I mean really fine limit diameters, 2 or 3 degrees C difference, or 5, 6, 7 degrees Fahrenheit difference of temperature can mean that you've blown your tolerance by the time the component has cooled back down to an ambient temperature. This is where this gets really scientific. In aerospace, things are measured in temperature, highly regulated temperature and atmosphere controlled rooms, because your standards that you calibrate your measurement equipment to are only calibrated at certain temperatures. So there's a whole manner of reasons when you're splitting microns or splitting tens of thousandths of an inch, you've got to have your measurement processes under really tight control. Now in a home shop we're not working at that level, but the same principle applies. If you're measuring something that's at 40, 50 degrees C, and then it cools down to ambient, say 18, 20 degrees C, you're going to be, depending on what material it is, because all materials expand and contract at different rates, but you're going to be way off what you measured it when it was hot. So that's one of the main reasons for coolant, is to keep things cool. But as I said, the other reasons of why, especially in a home shop, obviously tool life, as we've said, tools are expensive to the home shop, so the more life you can squeeze out of your tools by selective use of the right coolant at the right time in the right place is going to save you some cash on tools. There's another way of thinking about it as well, especially in a home shop where you've not got it heated 24/7. You're going to start getting rust and things like that. If you're tipping oily liquids all over your machine tools on a regular basis, there is more chance that you're going to protect them more from moisture, damp, rust, and the other things that you associate with a home shop that's not constantly heated. So they're the main reasons in a home shop that you would use coolant, really. It's tool life, consistent measurement, speed. Again, you could turn a diameter, let it get up to 40, 50 degrees and not have coolant, and then have to walk away from it for 2 hours until it's cooled down. If you've got some coolant that you can use, you get those 2 hours back and you can carry straight on with your job. So there's a whole manner of reasons, really. I could talk about them all day long, but largely the ones that I've just covered there. Okay, so where to use coolant? Well, anywhere you've got friction really is the answer. There's a plain and simple answer to that. So obviously on all of your machine tools is where you would start thinking about this, but don't think this is limited to machine tools only. If you're doing something on the bench, in the vise, tapping, hand tapping, hacksawing, anything like that, you've got friction, and an element of coolant will help that process. And don't just think this is about engineering. I'm going to break all the rules now and talk about one of these things. So this is a wood saw, and if anybody's ever tried sawing through wood that's damp or moist with one of these, you'll know how difficult that is. Stick 3 or 4 drops of that on your saw blade next time you're trying to do it, and see the instant difference it makes. It will help you cut through wet wood. So this isn't just limited to metal cutting machines. Think about the whole range of applications in a workshop in terms of the when to use it, and largely use it everywhere you've got friction would be my sort of advice really. The more you can use, the longer any tool is going to last, and that could be a hacksaw blade in your hacksaw, it could be a piece of high-speed steel in the shaper, it could be a carbide end mill on the mill, or it could be an insert lathe tool on the lathe, and so on. So anywhere you've got friction is when to use coolant. And an addendum to that, and all the textbooks will tell you, if you're cutting this stuff, which is cast iron, you don't need to use coolant. And certainly in model engineering circles, it's almost frowned on if you do, because this is full of carbon, it's self-lubricating, therefore you shouldn't use coolant. I fundamentally disagree with that. You know, by using coolant on this, you get all the advantages of tool life, of preserving your tools longer, keeping the part at a constant temperature to make measurements easier. You know, you're cutting this stuff, you've got friction, you're going to get heat, things warm up. All the advantages that you get of using coolant on any other material apply equally to cast iron. Plus, you know, and this is again from my industry experience, I've cut lots of this stuff on CNC machine tools in the past, and if you don't use coolant, the machine gets in a mess incredibly quickly. The stuff gets absolutely everywhere. If you're spraying the inside of the machine with lots and lots and lots of coolant, the machine stays much cleaner for much longer and needs far less maintenance. And it's no different on a machine tool at home. If you're washing that stuff away off your slideways with coolant, this stuff is really, it's not good having it left on your slideways at all. Once you've cut it, it's bad for your machine. So in my mind, using coolant on cast iron is probably far more important than using it on any other material, just because of that single fact alone. It wrecks machine tools, it wrecks slideways. Cutting it dry is fine, but cutting it wet is better. So, different types of coolant, what are they? Well, I'm just going to run through, a lot of them are obvious. Alcohol and WD-40, very good for aluminium, both of those. You know, largely I would stick to aluminium with those types of coolants, if we want to call them coolants. Now, you're not strictly using it as a coolant on aluminium because you're not putting enough on to keep the part cool. It's more as the friction reducer, surface finish improver, and to stop the aluminium welding itself to your cutting tool, which then ruins your tooling, ruins your surface finish. So you're not really truly using it as a cooling liquid in those cases. Neat cutting oil. Now, in my opinion, this is the best coolant there is of all coolants for many reasons. It's very expensive. You know, to be filling up big tanks on large machines with this stuff is not cheap, but it's really good at high pressure applications. So broaching, you know, even grinding, would you believe, you know, I've worked in machine shops where this stuff was filled in the coolant tanks of grinding machines just because of the properties it gives you. Now, you can imagine atomized neat oil with high temperature and sparks is a huge fire risk, and I've actually seen a machine, you know, a grinding machine go on fire in one of the workshops I worked in. You know, it's a massive risk, but the benefits are massive. It doesn't go off, it doesn't go stale, it doesn't get bacteria in it that starts to grow. It lasts a long time, and the results are incredibly good. It's probably the best coolant there is, in my opinion, based on my experience only. Moving on, you've got your soluble coolant, and there's many different types of those. There's cheap stuff like this, you know, the base levels, and then you can go up to like semi-synthetic soluble cutting oils. You can then go to fully synthetic soluble cutting oils. There's a whole manner of different ranges with different properties, widely used in industry everywhere and has been for many years. It's got its problems, you know. It's good it works well as a coolant, it works reasonably well as a friction reducer, and it works incredibly well as a machine tool wrecker, just in terms of bacteria and other things that it does to machines, and we'll talk about that a little bit in a moment. And then the very kind of last, and I'm not really calling these coolants, but again these are anti-pressure, anti-friction compounds. So you've got your sort of, it's a bit like neat cutting oil, sort of RTD type liquid roll oil, and then you've got your pastes like this for mainly for tapping operations and things like that. And again, these can be mixed with WD-40, they can be mixed with alcohol. I've seen paraffin mixed with normal engine oil. There's a whole different range of ways you can mix things up for different applications, and I'd be here all day talking about all of them, but largely they're the main range of different coolants, especially in a home shop, that you will or could be using. Okay, so how to use coolant. There's a million different ways to do this, so what I'm going to suggest is what I think's the best ideas, and that's again based on my experience through my career and through observing other things in engineering through my career time. So the rule of thumb that I would apply is the least pressure that you're exerting on your cutting forces, i.e. the least amount of friction you're producing, the least high pressure, slow speed cutting. So if you're high speed cutting, you know, with carbide like on a lathe, you know, this soluble coolant is absolutely fine. You don't need this type of stuff, which is the paste. You know, and as you progressively go more and more pressure with whatever your operation is, so you know, drilling's more pressure, and then you get onto broaching, which is a lot of pressure, slow speed. You get onto tapping, which is really slow speed and a lot of cutting pressure because of that slow speed. The thicker your coolant needs to be is a very, very simple rule of thumb. So this stuff is absolutely, this paste is absolutely ideal for tapping, and then there's a kind of graduation back up to the lathe where we're using the soluble coolant. Now, how to use coolant, there's many different ways, and I've often been asked the question, why don't I use proper coolant on my lathe and on my milling machine, you know, with a tank and a pump and all the rest of it? There's two very, very good reasons for that, and I've mentioned them before, but I'm going to go through it again. When you have a coolant tank on a machine, coolant goes off. This type of coolant goes off. Certainly the stuff that's not fully synthetic over time will go off. Why does it go off? Well, there's a few reasons for that. The first and main one is all of your slideway oil that you've got on any machine finds its way into the liquid coolant for obvious reasons, because oil floats on water. So this, you know, this stuff's 90% water and 10% roughly oil. So it's mainly water. So when you're spraying this on your slideways, it's going to wash your slideway oil off. It's going to get mixed up in the mix. It's going to go back down into your tank, and there it's going to sit and float on top of your tank. Now what happens then is your tank gets a thick film of what's called tramp oil, which is just all the oil from your slideways and from having used this stuff before where the water's evaporated and left a film of oil and everything. All of that goes into your tank. It covers the entire surface of your coolant, meaning the air can't get to it anymore, and it's an ideal breeding ground for bacteria. And bacteria start to breed, and it's that bacteria breeding that makes coolant go off very quickly, and it stinks awful, and it gets really thick and gloopy. You struggle to, you know, in an engineering environment, in an industrial environment, sorry, you really struggle to control the concentration of coolant when it starts to get like that. You know, we use refractometers to check the coolant on a daily basis, and you're either topping up with water or topping up with more of the neat oil to try and keep the concentrations right. It becomes an absolute pain to manage. And So that's one thing, and then the next thing you do is say, well, it's gone, I can't do anything more with this coolant, it's past the point of no return, I need to take it all out and put some fresh in. And at face value that seems like a good idea. So you take all your coolant out and you fill it back up with fresh coolant, and what's happened there is you've just put a load of fresh coolant into the tank that's full of bacteria, and the pump's full of bacteria, and your pipeline is, and your coolant tray is, and within 3 or 4 weeks you're back to contaminated coolant again. So when you get to that point, you've got to really strip your coolant tank out, strip your pump out. You've got to put biocides in to kill the bacteria off, which are nasty, horrible chemicals that you've then got to try and get rid of. If you look at my lathe, it's backed up against the wall. For me to get to the coolant tank, because I'm in a small workshop, I've got to fit it up against the wall. I've no choice. For me to get to the coolant tank, I've got to move my lathe, and I just don't want that hassle. So I use what I call a no-loss system, where I apply the minimal amount through a dropper bottle, and hopefully soon to be through one of these, which coolant mister, which I think is the best solution for a home shop, if I'm being honest, because you get the benefits of the coolant. So you've got pressure as well as coolant, which you don't get pressure using one of these, and pressure helps clear swarf and helps get the coolant where you need it, without all of the disadvantages of having a tank that you've got to maintain, clean out, disinfect and all that other stuff. And not only that, when you take the old coolant out of your tank, you've got to get rid of it. And if you're responsible, don't put that stuff down the drain, guys. That's not a good idea. It shouldn't go down the drain. You need to get rid of it responsibly, which means if you're very lucky, your local council waste recycling centre might take it off you. Highly unlikely. They will class it as trade waste, at which point you've got to pay somebody to take it off your hands. It becomes a very expensive business, especially if you're having to do that on a fairly frequent basis. So that's the first main reason I don't use coolant in the home shop. Now if I was using my machines day in and day out as a business, that's a whole different concept. At that point I would be using a coolant tank, and it would not be going off as quick because the coolant's flowing around the machine more often, it's getting aerated. I would have some kind of oil skimmer in my tank to stop a lot of that bacteria forming. So, but for the amount I use the machines, the worst thing for coolant is when it's got that film of oil on top of it and it's absolutely static and it's not being pumped around and it's not being aerated. You're not getting any fresh movement into it. That's when it goes stale very quickly. So something worth thinking about. That's the first main reason I don't use it. The second reason is I'm filming in here, and when it's splashing all over the place it makes filming really difficult. So by minimising the amount you put on, minimises that risk of it going all over the camera lens and ruining shots while I'm trying to film. So they're the two main reasons. In terms of how you would use coolant, again, it needs some thought. If you think back to what we discussed earlier in the episode, this is about the coolant needs to be right at your cutting edge. So if you've got a drill stuck right down a piece of material, a couple of inches deep, spraying coolant on the outside of the material, yes, it will help keep the material a bit cooler. Spraying coolant on where the drill's entering the material is doing nothing at all. It's absolutely all you're doing is wasting coolant at that point, because it's not really doing any good. The coolant needs to be right where the cutting edges are, deep in the hole, and that's why, again, in industry we have through coolant drills where the coolant's fired all the way through the drill, comes out under very high pressure right where the cutting edges are, and then that pressure can go nowhere other than back out through the flutes, which ejects all of the swarf up the drill, so you don't keep having to pull your drill out to clear the flutes and then put it back in when you're deep hole drilling. So yeah, just think about where you're squirting it. Painting this stuff on with a paintbrush on your drill cutting edges before you stick it in the hole and start cutting a hole with a drill, that's good for about 2 seconds. After 2 seconds all of that lubricant has gone off the cutting edges, so at that point you're not doing any good. All you're doing is creating smoke where the swarf is, hot swarf's passing by that paste on the flank of the drill. It's not doing anything at all to protect your cutting edges or do anything to reduce the friction. So the best thing you can do is retract your drill often. use something like this or a coolant mister and be squirting coolant, you know, down deep in the bore of the hole, and then carry on cutting that way. So it's thinking about that anti-friction, you know, anti-friction coefficient that you get from using something like this in between your cutting edge and your part. And that's true of all machines. You know, I've used a lathe and a drill as an example, but if you're thinking about how you're cutting and where your cutting edge is and where the coolant needs to be, that's when you'll start applying coolant properly. And the last thing I will say, and even though I've just sort of shouted this stuff down by painting it on a drill and sticking it in a hole, doing that is far better than doing nothing at all. So you're not doing any damage by doing it, you are helping a bit, but it's really not that effective. So just something to think about. And the final point, and I'm not going to labour this, is safety. And there's not too much to think about with safety, but you know, whatever coolant you've got, read the label. It's for your own good. You know, read the label, understand what's in it, understand how to use it. That's important. But more important than that, when you're using this stuff, this soluble stuff, I've seen people with dermatitis in industry that have got dermatitis from coolant. It's a horrible disease. If you've got any nicks or cuts on your hands, which we all have when we work outside in a workshop, and you get some of this stuff in it that's got bacteria in it, you can get dermatitis. And just think about what you're doing with your hands. Try and minimise the amount of exposure you're getting to your hands. If you've got cuts, put gloves on, especially if you know your coolant's not particularly in good shape. And if you go into the loo, wash your hands before you go, because if you've got it on your hands, you can get dermatitis in other parts of your body as well, which is an embarrassing trip to the doctors that nobody wants to have. So yeah, from a safety perspective, most of it's fairly straightforward, fairly innocuous. Read the label, and if you're using this soluble stuff, just protect your hands if you've got any cuts, because dermatitis is not a happy thing to have. Well, there we go, guys. That gets us to the end of this workshop tips video. So I hope you found that useful. Some of it, you know, it's not the most interesting of topics actually, but for anybody who's got a home shop and using coolant, I hope you found some of that interesting, useful. There might be some information in there that you weren't previously privy to. If it helps you, one or two of you, think slightly differently about how you're using coolants and what the best way of using it in a home shop is, then this video has been worth making. So I hope that's helped one or two people just understanding coolants in a little bit more detail, and hopefully helping you to manage the use of coolant in your home workshop. So we'll leave that at that. Hope that's hit the spot, Ralphie. So I hope that's you said I might be able to put it more eloquently than you, so I hope I've done that, and I hope people find it useful and interesting. So with all of that being said, we will catch you all very soon on another video when hopefully we'll be making something else.